This is the initial setup for the coefficient of friction activity. The purpose of the coefficient of friction activity is to examine the relationship between the mass of an object and how much friction force you get when you attempt to drag the object. We will actually measure the normal force, which is directly related to the mass of the object, and the force of friction. We will also compare the difference between the force of friction when an object's not moving and when it is moving. So as you can see, we're going to use this little block of wood. There's a Velcro side. We're just going to use the wooden side. We're going to do it on two different surfaces. This picture shows the block of wood on a table. You will also use this block of wood on the unfinished boards, and if necessary, we can have more than one group working on the same board. Those boards are long enough to do this. The process of collecting the data for this lab is pretty simple. As in the picture before, we have the force probe connected to the block by a string. This is 500 grams. You're going to start with 1 kilogram and go up by a half a kilogram each time. Having more weight gives us a little better data. Your force probe will be connected to your LabQuest, and we've used all this equipment before. So the first thing you want to do is, once you get this set up, your first thing is you zero the probe, and then you hit the green play button. And this is key. You want to pull very, very slowly. You want to avoid a big jerk. You're going to get a little one, but you want to pull as slowly as possible to find the minimum force it takes to make the block move. Once you've done that, you should get a picture. It looks like this. I pulled slowly and slowly and slowly, and then all of a sudden it moves and the force drops. So there's two parts. This is the force it took to get it started in the first place, and this is the force that it took to keep it moving. Once we collect the data, we're going to have to process it. And the way we process it, we've done before, but here's a reminder of how to do that. You're going to highlight you're going to do the max. We're going to find the max first, and we're going to actually do 3 trials for that, and I'll explain why in a second. So you go Analyze Statistics Force. You want the maximum value, so you'll have to find that. You're going to do that 3 different times before you do the second part, which I'll show you. The reason we're doing it 3 different times is the force it takes to start it tends to vary. Even though in theory it's supposed to be the same all the time, you'll find it bounces around. So to give us more consistent data, we're going to take an average of 3 values. The reason we don't need to take the average of 3 values for the force of friction when the object's moving is because we have lots of data. So when I highlight this part right here, I'm already taking an average. So when I highlight that and find the mean, I don't need to do that 3 times, because the one time I do it, I'm taking an average of all those numbers. But when I take the max, I only have 1 value. So that turns out that I have to actually do it 3 times. So in your instructions, it will tell you to do this, find this value, do it again, find this value, then do it one more time, find this value, and then after you've found the max twice on the 3rd set of data, when you find the max, then you'll go ahead and find the mean value of the level part of the graph. And again, you only need to do that once, because the process of finding this mean gives us an average, just like finding the peak does if we do it 3 times. So to remind you how to do that, you do it just like you did for the peak. You analyze statistics. You'll have to click on the force twice because it already has a check mark. And then now I have the mean, and that's the value I would put in the table.